Hi everyone, I'm Andrew Grove from Visor Accounting and Business Consulting, and today I thought I would share a few ideas on how some new technologies can be used to improve your business performance in the new year. If you have any questions, by all means go to our website at the-visor.co.uk and you can find my contact details there. Today, for the purposes of this video, we are going to imagine that we are the proprietors of a small manufacturing business called Adventure Boats. Adventure Boats is a small business, so customers have a lot of say in product design and in how they negotiate prices. However, going forward, Adventure Boats at least wants to stabilize its product design, and I'm going to show how this JavaScript animated dashboard, together with some associated technologies like open source algorithms, can be used to support this. So without further ado, let's have a look at Adventure Boats. Adventure Boats produces three different types of product. Product A is a rowboat, product B a canoe, C a skiff. In their manufacture, each of these products uses different amounts of aluminium, machine time, and labor hours. And each product produces a different unit profit. The resources are constrained, so in order to maximize the profit for any given production run, the problem is essentially one of selecting the right mix of products to produce. This type of problem can be easily solved with the method of linear programming. Linear programming is something that I looked at in high school, and we use charts to do so. On this chart, we can see the number of units of product A on the y-axis and the number of units of product B on the x-axis. The solid diagonal lines represent the various resource constraints, and the area that they bound is called the feasible region. The feasible region shows all the possible combinations of units of A and B which can be produced within the given constraints. The dotted line is called the objective function, and this depends on the unit profits of product A and of product B. And the linear programming problem to maximize the profit is essentially one of moving the objective function as far from the intersection of the axes as possible to where it just intersects with the feasible region. At this point, the number of units of product B and A will maximize the profit. Now this chart, because there are only two axes, only allows us to look at problems with two products. However, you can look at problems with as many products as you like using Microsoft Excel and its solver tool. What I have used for my JavaScript dashboard is a linear programming algorithm that I've downloaded from Node Package Manager. So I'm not going to talk about the Excel and solver tool. If we have a look at this diagram, we can see all the variables for the production of Adventure Boats. We can see that the inputs of aluminium, machine time, and labor for each of the products varies for production runs currently. So that's the design, varies. Also, the unit profits vary because the customers negotiate prices. And even the resource constraints vary because suppliers are inclined to have some leeway in what resources they will grant me for the different production runs. Now going forward, Adventure Boats wants to at least stabilize its product design so that this stays fixed from one production run to the next. My finance team has very kindly set up this linear programming or this JavaScript animated dashboard for me. And what I can see here is in the top left-hand side, I can see the various resource constraints for the different production runs, up to 10 production runs at a time. I have changed these to equivalent units so that I can plot all of them on a single set of axes. Similarly, on the lower left-hand side, this stacked bar chart shows me the equivalent inputs for the different boats for the different production runs. So for aluminium, how much is used by A, B, and C, machine time, how much is used by A, B, and C, and labor hours, the same thing. The table here shows me for the different production runs what the unit profit is that is achieved for different products. And I can also see the number of units that I have produced in my production runs. I have also asked my sales team to come up with a static design as a first cut, and I'm using my linear programming algorithm to look at the different parameters from my actual data, so the resource constraints and the unit profits, and then to apply the static design inputs to calculate how many boats of each type I could produce under that design. Then what I'm doing in this line chart is I'm plotting on the red line what the profit is achieved for a production run using my current volatile data, so this is historic data, and what that profit would have been using the static design. And when I stream through my different data sets, so as I'm interrogating different data sets of the production database in the background, I can see that this test design's profit is consistently lower by about sort of 30 to 40% on average for any given 10 production runs. And this is because my sales team hasn't been very efficient in how they've put together the spec for that design. So I can produce fewer boats on that design than I currently do with my volatile design. And this means that my profits are always going to be lower. However, I have also spoken to the design team myself, and together we have come up with a more resource efficient design. And if I just switch that on, we can see that immediately that closes the gap to a large extent between the static design and the volatile design. And the gap between the profits now is only about, 2 to 5%. And that means that it's probably quite feasible for me to settle on a static design which will give roughly equivalent profits to what I'm currently getting. So that's feasible. Something also to note here is that I'm using a linear programming algorithm to give me outputs of test data where I've inputted test design data. However, if you have a business performance indicator, might be profit, might be something else, and you want to input test data against what your production data inputs provide, you could probably train up a machine learning algorithm and have that running instead of the linear programming algorithm, where you've used your historic business data to train up the machine learning algorithm, and it's now at the point where for a given set of inputs, the machine learning algorithm is capable of anticipating what the associated outputs will be. So that algorithm is obviously a lot more diverse in the types of problems it can solve than a linear programming algorithm, which might be fairly fixed in its remit. I have also on my custom dashboard here got functionality where I can select specific design parameters one by one, and I'm just going to demonstrate how I can use that to push up the resource requirement for product A to the extent where product A won't be selected ever going forward, and that essentially helps me rationalize my product set going forward. You can see that the effect on the profitability is not too dramatic. However, there might be other reasons why I don't want to rationalize my product base. For example, if customer preferences change, maybe it's better for me to have a more diverse set of products in my offering so that I'm not missing out on a big chunk of unit of business in future. So those types of problems are not something which can be gauged just from an algorithm, but it's worth bearing in mind that there are other factors to apply. Anyway, I hope that this has demonstrated how having a live data set, or at least a dynamic data set, it could be a live data set if we're looking at a stock market index or Amazon sales or something like that, and I'm actually interacting with the streaming data on a live basis. But I hope that this has demonstrated how this type of functionality can provide you with very intuitive and valuable tools to analyzing business performance in future. If you have any questions, by all means contact me, and all the best for 2021. I hope to see you in the next year.